Your AI assistant just asked to roll some dice, and with one simple request, it used your custom tool to generate results. No manual API calls, no complex integration work. We'll see exactly how to connect Anthropic's messages API to a FastMCP server, so your AI can securely call remote tools like this dice roller with just a few lines of Python. You'll configure the server URL, pass authentication, and watch the AI execute the tool, all in real time.
Import Anthropic. From rich, import print. Hash your server URL. Replace with your actual URL. URL equals https:// your server URL.com. Hash your access token. Replace with your actual token. Access token equals your access token. Client equals Anthropic. Response equals client beta messages create. Model equals Claude Sonnet 4-20,250,514. Max tokens equals 1,000. Messages equals roll. User content. Roll a few dice. MCP servers equals. Type URL. URL. FURL/MCP/. Name dice server. Authorization token. Access token. Extra headers equals Anthropic beta MCP client 2025-04-04 print response content.
This demonstrates the remote tool integration pattern, where external services expose callable functions to AI models through a standardized interface. The concept revolves around decoupling tool implementation from AI orchestration, allowing models like Claude to dynamically discover and invoke remote tools as if they were native capabilities. What makes this distinctive is the seamless bridge between arbitrary backend logic and AI workflows, without requiring model retraining or custom integrations. The pattern works by establishing a contract between the AI client and tool server through a discovery protocol. The server exposes its tools via a well-defined endpoint, /MCP/, while the client, Anthropic's API, queries available tools at runtime, handles authentication, and manages the execution flow. This creates a declarative system where tools are self-describing through type hints and doc strings, eliminating the need for manual API documentation or client-side stub generation. The separation of concerns means developers focus on tool logic, while the framework handles transport, serialization, and error propagation. This approach solves the problem of AI tool fragmentation by providing a universal integration layer. It enables rapid iteration, where you can add, modify, or secure tools without changing the AI prompt or client code. The trade-off is the initial setup of the MCP server and authentication layer, but this cost is offset by the ability to reuse tools across multiple AI models and clients. It's particularly valuable for scenarios requiring dynamic tool sets, like game mechanics, data processing pipelines, or multi-step workflows where the available tools might evolve over time. Let's break it down.
Import Anthropic. From rich, import print.
This imports the Anthropic SDK for Claude API interactions and print from rich for enhanced console output formatting. The rich library replaces Python's default print with syntax highlighting, tables, and better readability for complex responses.
Hash your server URL. Replace with your actual URL. URL equals https:// your server URL.com.
This defines the base URL for your MCP server endpoint. It's a configuration placeholder that must be replaced with your actual server address before deployment, ensuring the client can locate and communicate with your custom MCP service.
Hash your access token. Replace with your actual token. Access token equals your access token.
This is the authentication token for the MCP server connection. It authorizes your requests to the external dice rolling service, preventing unauthorized access to the endpoint. Always keep this secure and never commit real tokens to version control.
Client equals Anthropic. Anthropic.
Instantiates the Anthropic client, the main entry point for all API interactions. This single client instance handles connection pooling, authentication, and request routing to the Claude API and any configured MCP servers.
Response equals client beta messages create. Model equals Claude Sonnet 4-20,250,514.
This specifies the AI model to use for processing the request. The Claude Sonnet 4-20,250,514 identifier selects a particular model version, ensuring consistent behavior and preventing unexpected changes from model updates. The beta messages create endpoint is the new interface for structured, multi-turn conversations.
Print response content.
Outputs the API response content to the console. This is the final step that displays the dice roll results or any errors returned by the MCP server, making the output visible for debugging or user interaction. FastMCP client integration. This pattern demonstrates how external MCP servers become first-class citizens in AI workflows, with the client handling authentication and transport, while the model treats remote tools as native capabilities. The authorization token parameter in MCP server's configuration is mandatory for secured endpoints, yet its absence produces HTTP 400 errors rather than immediate connection failures. Always verify your server's authentication requirements, match your client configuration before making requests.
The client that speaks to no server still receives an answer.